We're doing it. Hi, everyone. My name is Rob. I'm glad everyone is here today. Hope everybody's getting ready for a great holiday. Today, for our data chapter meeting, we have Mohammad here. He's going to be talking about big data clusters for the absolute beginner, kind of like me. Can't wait to see it. Thank you, Mohammad, for coming on today. We'll go to the next slide here. So next month we have Tim. He's going to come in here and do Azure Managed Instances. That looks pretty good. And I also have a friend of mine. I've asked him to come in and talk about what's new in SQL Server 2019. I actually got to see this presentation, and I really was impressed. So I asked him to come on. So we're going to do 2 sessions in January, which is awesome. So please, if you have time, check it out. I'd like to thank HVR. They give us money to give away, and they also sponsor our group. So we're going to give a little money away today. We'll just pick someone, check your spam, because it'd be a shame if you got spam mail. It was really money. Kind of weird, but you may get money. So check it. It'll come from us, and you could be a winner. So pass. The Board of Elections results are in. Here are the winners. I hope everybody had a chance to vote. Let's go to the next one. And if you missed Summit, they always have stuff you can check out. So if you go to this past stuff collection, you can see that information. So the next there's a virtual group webinars upcoming, and you can see ours is there, Cloud is there. Lots of good stuff coming down the line. More webinars coming up. Wow, there's tons. So if you have a chance, check them out. They're all free, doesn't cost anything. Let's see. There are a lot of virtual groups in PASS. So if you have a chance, is there something interesting? Sign up, and they probably have a webinar that's going to be very valuable to watch. And upcoming SQL Saturdays. So if you're in Washington or Nashville, you may want to check it out. And with that, I'd like to thank everyone here today, and I'm going to change it over to Mohammad. Hey, Kenny, can you switch it to Mohammad?
Well,
I'm going to try. Oh, you got it? Oh, hot dog.
Let's see.
Got you live, Mohammad.
Good, awesome. I hope everybody can see the screen is fairly simple, has a QR code and that link. That QR code goes to the link. I hope my audio is also decent, because I know these webinars sometimes they kind of suck. So I hope it's good.
You sound really good, Mohammad. Just FYI.
Awesome. Thank you. I'm super excited. I wanted to thank also, like you mentioned, the sponsors, you all, for allowing me to speak at this group. I'm super excited about big data clusters, and I want to actually put this presentation together. The abstract was a little difficult for me because, again, I was an absolute beginner about a year and a couple months ago, but the angle I wanted to come and present this information to you all was kind of a little hurdle I had to jump, right? And I'm from the DC area, and a lot of work that I do, unfortunately, with the government is outdated, right? So working with SQL Server 2008, 2008 R2, and when I do this talk at SQL Saturdays where I can actually see the people, I ask, right, how many people are still using these old technologies? And there's a fair number of hands do go up, right, unfortunately. But we can't really control, the places where we work and the technology that they adopt. But with SQL Server 2019 and big data clusters, that really kind of piqued my interest with the technology behind it and a tool to be used to make us relevant again, right, with this cutting edge technology. And I'll talk about that as we go through this. So if you feel like you're working with outdated technology, hopefully after this session, you have this, energy, right, this spark to just hit the ground running, right, with this cutting edge stuff, which is technology. There's some learning curve to it, but at the base is SQL Server, which we've been, SQL Server professionals anyway, right? So again, my name is Mohammad Darab. A little bit about myself. Like I mentioned, I am from the DC area, close to 20 years in IT, and that's how I keep myself feeling young. I say 19 plus instead of just like rounding up to 20. And 10 plus years working with SQL Server, right? this year, that's actually, it wrapped up in PASS Summit 2019, I was an IDERA ACE. So all that means is that IDERA sponsored a lot of my sessions, my speaking engagements around the country this year, and I wanted to thank them for that. Online, mohammeddarab.com, I'm very active. And if anybody goes there, and they'll see I'm focusing heavily on big data clusters. So I just don't do this presentation and leave and say, all right, bye. I have a lot of the information there. On Twitter, if you're active on Twitter, I really encourage you to reach out. I like to say active myself on Twitter at MW Darab. So the agenda. This is kind of like a rough agenda right here. We're talking about the history, what is a BDC, the definition, right, from a Microsoft point of view, the architecture, so I give you a bird's eye view. If you're like me, you have to kind of sometimes see it to believe it, right, or like you're a visual learner. I like to see a lot of images, some of the features, licensing and cost that since SQL Server came out general availability recently, a couple of weeks ago, now we have that information, right, with big data clusters. And then a learning path. So this is very important. I'll leave you today, and again, you see the link at the bottom, /BDC, with a place to go, right, where you have videos that I've done, blog posts that I've done, things that even this session you'll find there. So you don't need to take notes. You can just sit back, relax, and dwell in the confusion that's about to arise. Right? And don't worry, because there's a lot of information here, but we're going to tackle it. So let's get started. First, history. Now, if you all are familiar with SQL Server 2016, I'm sure a lot of you all are probably using it. They introduced a feature called Polybase, right, which allowed you to connect from your SQL Server relational database, right, and connect and query data that's sitting on a Hadoop, like a Hortonworks, Clouderity's Hadoop services, or Azure Blob Storage, and you can read Hadoop, right? I remember when this first came out, back in end of 2015, 2016, I attended a user group meeting. They presented this, and it had nothing to do with what I was doing. Because back in that time, I was working with, I think it was like even 2005, 2008. So 2016 was like, there's no way I'm going to be using that. Big data doesn't even relate to me. I didn't really, I understood conceptually what it does. It kind of interesting, but really didn't connect with me at the time. Not that many people actually use Polybase, at least from the people that I ask, right? And then the year after that, SQL Server 2017, excuse me, they added support to run SQL Server on Linux. This is huge. This is huge, and you'll hear people, like the engineering team, the product team, like Bob Ward and these individuals. They, this is actually huge. And if you actually heard the story, the idea and the projects and how they decided to, hey, let's put this on Linux, it's amazing. And as a result, you can actually deploy an instance of SQL Server running on a container, right? So we'll talk about the containers and all this stuff in a couple of slides, but that's what 2017 brought to the table, right? Huge. I actually remember when I first heard that SQL Server was being supported on Linux, very first question I had, maybe you all had the same question. I thought, who would ever need that, right? Like, who would run SQL Server on Linux? I just had the why. Right, and then kind of left it as is because I'm a Windows guy, command line and Linux and all that type of stuff for me is foreign. So 2019, now they have something called enhanced Polybase, right? Or Bob Ward likes to call it Polybase plus, right? The next version of Polybase. Now, with the initial Polybase in 2016, you can connect from your relational database server, right, SQL Server, to Hadoop. Right, you can query to a Hadoop service. Now, with this enhanced Polybase in 2019, they've added the Spark engine, right? So you can still do Cloudera and Hortonworks if you're looking at the right side of the image or lower right-hand side. As you move to the left, now you can actually query Teradata, relational database, Oracle, right? Another instance of Microsoft SQL Server. And then you can, now they even included NoSQL, like MongoDB, Azure Cosmos DB, right? And then your ODBC connections. So they really expanded, the ability, right, to sit from your SQL Server and query. I mean, to me, the biggest thing right here is that you can sit on your Microsoft SQL Server instance, right? You log in and query Oracle. You don't have to, deal with SSIS packages where you're selecting data out of Oracle, scrub it, put it in this and that, and you just select the data from Oracle, right? So when I first heard about this, it really piqued my interest. Okay, so what's going on with Microsoft, right? What are they doing, right? And I'm not privy to any behind the scenes and secret information of what's going on at Microsoft. So for me, it's like hindsight 2020, right? I got to wait till it comes out. Then I'm like, oh, that's why they're doing that. And at the same time, they also allowed you to have an availability group utilizing Kubernetes technology, which we'll also talk about Kubernetes as well in a couple slides. Again, if you're confused or if you're like, what the hell are containers of Kubernetes? Don't worry about it. Don't worry. Okay, it took me a year and I'm still learning every day. So just relax and go along with the ride. So when I do this session in the past, people usually have some questions, right? And some of the questions that I've been getting, that's pretty much the same question is, what's the difference between Polybase and link servers, right? And the difference right there, I have it up there for you. Polybase, starting from the left side, is database scoped, right? And link servers instance scoped, right? Polybase is more intended for analytic queries, processing large number of rows, right? Link servers ideally should be just for OLTP queries, returning like one or two, a couple hundred rows, whatever, that's it, right? Now, I have worked in environments where they use link servers, right, to process hundreds of thousands of even millions of rows, data warehouses and stuff like that. And then link servers always fail. There's always some problems going on. Hold on. Okay, I just had to read the comment here. I just hope everybody can still see the slide. If not, please leave it in the questions or chat. So with link servers, there's some issues, right? With Polybase, they don't have those issues, right? They're more specifically for big data, for example, like Hadoop, right? If you have an AG, no separate config needed for Polybase, but for link server, you need for each instance, you need to reconfigure that thing. So, like I mentioned, containers. If you're a DBA like myself, your background is you're just a regular old production DBA. You don't really have much information or knowledge about containers other than everybody's mentioning containers. That's it, right? Docker containers. Just to clarify if there's a little confusion on what Docker is a company, right? So if you go to docker.com, that's a company, and the company created the Docker engine, right? And it's a container service, right? And they have the API, they have all these different technologies that utilize the Docker engine. And now they kind of associate that name Docker with the containers, right? But the container technology goes way back and has been Linux-based, Unix-based forever, right? It's just now starting to come onto Windows. But pretty much a container, think of it as literally what it's called, a container or a box, right? And I usually like to think of it as a huge shipping container. The shipping yards, the big metal huge ones where they usually have those arms that come out and like pick them up and shift them and move them around. Those containers, right? Imagine if you fill that container up with all the pieces you need, all the files, everything that you need to run an application, right? Now you can pick up that container and move it anywhere, and that application will still run fine, right? That's pretty much the gist of containers, right? To containerize the application, right? Or the service or whatever it is that's running, right? That very, very crucial, right? So as you probably already read here on the monitor, it's a standard unit of software that packages up the code, all the dependencies, like I said, right? So the application runs it quickly and reliably from one computing environment to another, right? So if you have a container running on, let's say, Windows Server 2016, and it's running all perfectly fine, right? But that's for example, your prod environment, right? And you want to go ahead and use the same files and everything. You want to run it on your dev or UAT other environment. You just pick it up and just shift it. It'll work fine, right? If it's working fine on the container, it'll work fine on another host, as long as the underlying host is the same OS, right? Again, I always want to preface this, and usually when I'm talking, I can actually see the faces. I do see some people like kind of confused. Do not worry, right? At the end, I'll leave you with the learning path, and that should help shed more light on the matter. So now that we have containers, these going back to that analogy of the shipping dock, right? The shipping containers, we need something, right? Or some type of technology to orchestrate that, right? To control that, to be in charge of those. And going back to, again, my analogy where that arm I have to probably look it up. I keep using it as an analogy. I don't know the specific term, but that big arm that comes on and grabs the shipping containers, right? That, I like to view that as, in a way, not exactly, but in a way, Kubernetes, right? So Kubernetes is that container orchestrator, right? Or even better yet, think about it like a conductor, right? at a symphony, right? People are playing music, and at the swing of his hand, right, he has a stick. I know you don't even call it stick. There's probably a proper word to call it. He can silence some instruments. He can begin some. He can raise them and lower them. He's in charge of the music, right? That's what Kubernetes is. Originally started by Google, right? So now everybody uses it, open source, and it's a container orchestrator. It can be in charge of scaling out, scaling in. If a certain, which we'll talk about the nomenclature for Kubernetes in a couple slides. If one of those dies, right, for some reason fails, Kubernetes is in charge of bringing another one up, right? Let's go on to the next slide here. But everything happens within a Kubernetes cluster, okay? So I would like to think of it as whenever you hear the term Kubernetes, right? It's synonymous with Kubernetes cluster. Kubernetes in itself is just, it's just a name, right? You have to create a cluster and then tell a cluster to do stuff. And that's where Kubernetes really shines, right? So looking at the slide here on the right-hand side, you see the shape inside. There's smaller, what is that, like a hexagon, right? A heptagon. You have the main master in the middle, right? And then you have the worker nodes. They call them worker nodes. They got the master node as the main one, and you have the worker nodes that are the rest. They just do the work, right? And the nodes can be machines, right? It can be physical machine or virtual machines. A node can, right? And again, the master is in charge of work distribution between workers and monitoring the cluster health, right? Let's dive in a little bit deeper into a node. So like I mentioned, a node runs containerized applications, right? It can be a VM or a physical machine, right? That's a node. So when you're looking, see if I can use my mouse here. Here we go. You see these two. So this can be a VM here. This is another VM, right? VM. So each one of these are its own VM or physical machine. Oh, there we go. So a pod, this is where the confusion started for me. And if it starts for you, don't worry, you're not alone. A pod is the smallest logical unit, right, that Kubernetes deals with and handles, right? It's in charge of a pod, right? It's like the atomic size, right? It's the smallest thing that Kubernetes deals with. It's just a logical group of one or more containers and associated resources. I have an image, and on the next slide, it'll really really expand your understanding, hopefully. And a pod runs on a node, and a node can run one or more pods. Now, if you're confused like I was, and even now I got to read a little bit slowly, right? I'm not the sharpest tool in the shed, right? Don't worry, the next image will hopefully clarify the gist of what I mean by that. So I actually created this image, I think it was last night or night before. Let's start from the left-hand side, right? Image. This can be your, and let's stick with SQL Server, just because we're, I'm assuming we're SQL Server professionals, right? That's your SQL Server image. So Microsoft now has a public repository where they upload their SQL Server image for, let's say, 2019, right? You can go and download that, right? Now, if I install, let's say on my own laptop, I have a Windows 10 Surface Book, right? I install Docker for Windows, right? It has a little desktop, little application. I download the image and I instantiate it, right? Or I run it, right? Now a running image becomes a container, right? That container is a running image. So starting from the left side, image, when you run it, becomes a container, right? So now that image is in the container, you can access SQL Server, everything is fine, everything looks normal. Now, the next three squares, right, or rectangles, whatever they are now we're getting into the Kubernetes cluster world, right? So the next one over is a pod. You see that container? You can have, just a preface before we actually go on to the pod, the image is a service. Let's look at it as a service. So a single service can only be on a single container. You can't have two separate services on one container, right? Meaning like you can have one container with Spark service running and then also SQL Server running. No, you have to have one service per container. Now, you can have multiple containers on a pod. Now we're going over to the right. You see one is running Apache Spark, Hadoop, and a SQL Server, right? 3 different containers running 3 different services. Now that entire pod can be put onto a node. which was at VM or physical machine that we mentioned in the previous, right? So if you look at it, under the node box, we see the pod with 3 different services, and we have 3 of those, right? So you have 3 pods running 3 different services of Spark and Hadoop and SQL Server, right? Now you take that node, you have multiple nodes, right? If you create a cluster, obviously you're gonna have more than one, right? And you're gonna put it into a cluster. Now you have your master node and you have your worker nodes, right? And hopefully this image makes sense. If not, please reach out to me if you have any questions, either here or later, and I can help clarify. But hopefully that should thing. And by the way, this will be available. The deck is available on the link below, so you can download it, view it, whatever, and reach out to me with any other questions. So all of this and why, right? The question is why? Why is Microsoft doing this, right? Why is Microsoft doing this with SQL Server, right? I want to share a couple of pieces of statistic with you all that I came across that was mouth dropping for me. Maybe you all have heard of it and read it, but if not, I'll love to share this with you. Take a second to read that. So 90% of all data today was generated in the last 2 years. One, I want to say, is that this was, I think, a couple years ago. So maybe today that's like what, 93%, 95%, whatever rate that it increases, you know. And I usually ask the people in the room when I can see them, I ask them, what do you think that the majority of this data is, right? Especially over the last couple of years, right? What do you think that it is, right? And you know, hands go up. I'm like, okay, and they blurt out social media, right? A lot of it is social media and just information. I mean, data just like that. And for the most part, you know, based on the sector, right, the industry, they're right, right? I want to share another piece of information with you, kind of bolster this claim of it being social media, right? And this was also mouth dropping for me as well. I guess it isn't mouth dropping, it's jaw dropping. My wording was so jaw dropping. So Walmart collects 2.5 petabytes, right, of data from 1 million customers every hour. Okay, every hour. They have information on over 160 million customers. Right? This is Walmart, by the way, the place that you go and shop, right? Billions of Facebook messages, tweets, and all that stuff, right? If you got a blog, you got a Yelp review, everything, they just suck it all up, right? The question becomes why? Why the hell are they doing this? Kind of eerie, right, in a way, right? Read this quote from Walmart CEO back in 2013, I believe. Pretty eerie, huh? You can replace Walmart CEO with Dr. Evil, right, from Austin Powers, right? We want to know what every product in the world is. We want to know who every person in the world is, and we want to have the ability to connect them together in a transaction, right? A little sinister, right? It's not like, oh, we just want to, you know, we want to do good in sales, right? It's like they want to know everybody, right? And so, and if you all are not familiar with Walmart Labs, right? I'm actually, I found out about this a couple years ago, but a fair amount of people that I speak to don't know about Walmart Labs, right? So Walmart Labs is like a subsidiary or like a little division of Walmart that just aggregates and collects all this data. So if you go type in jobs at Walmart Labs, look at the jobs that come up: data scientist, you know, PhD, this, that, whatever, everything data related, right? Data analytics and stuff like that. That's what they use that subsidiary for, to analyze all that. And just to give you a tidbit, a little story, right? Because I mentioned that I have a bunch of stories, and here's one before we move to the next slide. Walmart, with all this data, they started to see that during certain times of the year, sales of strawberry Pop-Tarts spiked 7 times, right? So it'll be like 1x, 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 and then a certain time of the year, boom, 7x, and they go back down to 1x. They started to get a little curious. What the hell's going on? Doing their, you know, big data analytics, right? They correlated a bunch of different factors, weather, time, blah, 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 and they found out that whenever it's hurricane, right? Whenever a hurricane comes down in Florida, right? The sales of strawberry Pop-Tarts increase. They took that information, right? And now whenever there's a hurricane, they move strawberry Pop-Tart front and center. So go figure that out, right? I gave this talk in Orlando and I said, what the hell is up with y'all Floridians over here now with the strawberry Pop-Tarts, right? But that's what they do, right? So they want to make sure that they can maximize profits, and that's pretty much what it comes down to, right? You want to save money and you want to maximize your income, right? So that's and that's just the retail sector, by the way. This is just one company, Walmart. Now, what does SQL Server have to do with this? Just like everybody here, and I assume, like I want to be relevant 2-3 years from now, right? 5 years from now, 10 years from now, right? I want to be relevant with not just a certain feature in SQL Server, like, oh, they came out with a new feature, whatever, like secure enclaves or whatever, right? No. This big data clusters is a whole different game, right? This is a whole different game. You are being, you're going to be current with cutting edge technology that goes beyond just SQL Server. So just like we want to be relevant, SQL Server is like pick me, right? I can do it. Yeah, the past 25 years I was doing relational database, all that stuff, but now times have changed, right? Didn't you hear the Walmart CEO wants to know everybody and every product and put them together in a transaction? I can help you do that, right? So Microsoft, as SQL Server, is saying, I can do it with big data clusters. I can do everything. And now we're like, what the heck is big data clusters, right? So let's start getting into the Microsoft definition of what big data clusters are. I'll give you all a second to read that. I'll go over it in a minute. I can take a little water break. So if you read this and you're confused because there's a bunch of keywords and buzzwords that you probably heard but haven't looked into, don't worry about it. BDCs allow you to deploy scalable clusters, right? Now, scalable clusters, we're talking about Kubernetes, right? To be able to scale, right? Of SQL Server, Spark, HDFS containers running on Kubernetes. Now, Spark, I'm sure you probably heard of it if you're not familiar with it. I like to look at it as what T-SQL is to SQL Server, right? T-SQL. Spark is to HDFS, right? Hadoop. You got to query, you got to, you need a language, right, to go ahead and access the data. That's Spark, right? Running on Kubernetes. These components are running side by side to enable you to read, write, and process big data from T-SQL or Spark, right? There's a comparison right there, T-SQL or Spark, allowing you to easily combine and analyze your high-value relational data with your high-volume big data. That link will take you straight to the Microsoft website, right? So what does all that mean? That means that now SQL Server, your big data cluster, right, is an AI machine learning platform from end to end, from the left to the right, right? Data coming in from the left now, right? Unstructured IoT devices, SQL Server on Edge, anything, it can come in straight into your SQL Server big data cluster, right? Ingesting it via those methods right there and more. Those are just two, Spark Streaming and Kafka, right? Storing it with HDFS, your SQL Server data pools. We talked about the pools in a couple slides, right? Move on over, we prep and train it. That's where the, smarty pants people come in, right? Data scientists, data analysts, they come in, they do all of their, all their mathematics stuffs, right? They do all of their machine learning stuff, and then they model it and serve it, right? And on the other side, you got your predictive apps, your Power BI, all these tools that come in and just read the data, right? You go take it to the Walmart CEO, and then he says, okay, now push the strawberry Pop-Tarts in the front. That's all that happens, right? So all of this, and now let's talk about the architecture. Kenny Neal says strawberry Pop-Tarts are delicious. Again, if you're like me, you like to see things visually, right? To kind of give a little bit of a better understanding. I mean, not all of us are John Nash, right? So let's see this image right here, straight from Microsoft. The only thing I did to this was I modified the colors, the light green bold and the black and the red, right? The green rectangle right there, let's focus on that a little bit right now. That is a big data cluster. Everything inside that green bolded rectangle, and the big one right there, right? On the upper left-hand side, you see the controller, the big black bold little, not little, I guess, rectangle right there with the control service, a proxy, Kibana, all that stuff. That is actually, should be inside that green big data cluster. It's part of a big data cluster, but they have it out because I guess, actually I reached out to Microsoft. I was like, is this like part of the big data cluster, or is it not? Because visually people are like, what does that mean? And they said that they just didn't have space to put that in. So that was like a design issue of an image issue. So, but anyway, that goes inside. Now let's break these down. Before I do, your attention to the black bolded objects inside the green. Application pool, starting from the left, right? Data pool, compute pool, storage pool. Now, us as data professionals, we've been working with, SQL Server or some type of data platform for a while. These you can probably take a wild guess and be right on what they do, right? So let's kind of go into each one of these real quick. So the controller, right? When you deploy a big SQL Server big data cluster, the controller is built first. Then it takes care of everything else, right? The SQL Server instances, the interaction with Kubernetes, HDFS and Spark, it does all that. So when you deploy a big data cluster, the first thing that happens is the controller gets built, right? Provides a cluster lifecycle, bootstrap, delete, update, everything that controller is in charge of that. Hence the reason why they call it the controller, right? Now the master instance right here is where we as data professionals log into, right? SSMS, Azure Data Studio, whatever it is, we need the master instance endpoint or IP address, and we can just connect. Easy, just like we normally do, right? Provides connectivity again, like I mentioned, right? And it has a scale-out query management, right? So the master instance, if you're querying data that is in, let's say, in Oracle or any other place, that query, the scale-out query management feature will know when to push, right? The computation or the push-down compute of that query to the compute pool, right? That's where you can enable the feature, right? The machine learning services on the master instance. That's where it happens, right? So again, the smarty pants people, right? Java, R, Python, they use these things to do their whole machine learning and all that stuff, which I'm not that at all. The compute pool, right? Like the name says, it provides computational resources, extra computational resources. This can also be scaled out, right? So if there's times of, in your business where, let's say, at the end of the month, there's all these invoices and stuff that are going out, a lot of churn and burn, you can increase, or you can scale out these instances, right? And by the way, each one of those red rectangles is an instance of SQL Server, right? So if you're also kind of in the back of your mind, like, I wonder how much licensing will cost for all of this. Don't worry, we'll address that as well, right? Compute pool. The pods in the compute pool are divided into SQL compute instances for distributed queries, specifically Polybase. Again, what do you use Polybase for? Go connect to your Oracle, connect to Teradata, right? Connect to another SQL Server instance, right? Connect to your Hadoop, right? That's what a compute pool does, that distributed queries, right? Data pool. Now this is stored for data persistence and caching. So like you go and do your query and you bring the result back, that is stored in the data pool. So your next time around is not going to be that long, and now you start to create these so-called data marts, right, in your data pool. All this cached data is inside the big data cluster now as these data marts, the individual little marts. The storage pool. So the storage pool actually has your SQL on Linux, your Spark, right, service, HDFS, all that working together, right? Now, if you look at that red box right there, you see the red box? You have your Spark service, your SQL Server service, and your HDFS service, or your Hadoop service, right? Running on that Kubernetes pod, right? And they're all meshed together, interacting with each other as, I mean, just kind of think about it like a symbiotic relationship between services that I thought would never come together, right? SQL Server and Hadoop and Spark, like it's amazing to me. I mean, as I was researching this and learning this, I fell in love with it even more and more and more. So again, the storage node is responsible for data ingestion through Spark, right? Data storage. So when you store data in your HDFS cluster, it's in the storage node, right? Now we're talking about storage, and I want to tell you a quick story. When I first heard about Kubernetes and what Kubernetes does, by the way, if you haven't figured it out already, and if I've missed this, I apologize, but there is no big data cluster without Kubernetes cluster, right? Without Kubernetes, right? The only reason that big data clusters exist is because Kubernetes exists. Because Kubernetes is a base of all the other services that are running in pods, like these storage nodes and the compute pools and all the different things are running in a big, huge Kubernetes cluster, right? So when I first heard about Kubernetes, a friend of mine said, you know what Kubernetes can do? And again, I'm a production DBA, right? I'm like, I don't know what, I heard of the name, I don't know what it does. He says, imagine if you have a server, database server, a couple, and even let's say if you have it in an AG, availability group, right? One server goes down, it'll automatically, Kubernetes will recreate the services needed to keep that up and running without you even having to fail over or synchronize and fail over, anything like that. Just like in an instant, you won't even notice. And then he used example of like Gmail, for example. Everybody uses Gmail or something like that. That's what they use in the background, containers. Maybe I'm thinking maybe like millions of containers that probably die and be recreated every day. We don't even know, right? When was the last time you had a Gmail outage, right? I was so excited when I heard that, right? I was so excited partly because I'm lazy and I don't want to do any work, right? So I'm like, hold up, so I don't have to do anything? I just wait and sit back and Kubernetes takes care of everything? He said, yeah. I was like, okay. I went ahead and I called my mentor friend from about 10 years ago that he got me into actually SQL Server, and he's an older gentleman than I am. And I said, hey, have you heard of Kubernetes? He's like, no. I was like, damn, okay, well, it does this. And I reiterate what my friend said. And he says, okay, but what about storage? I'm like, damn, I didn't know. So I had to hang up and I had to go research on how does storage work at Kubernetes, right? Because if you're working on a production database server, you can't just have the data disappear. It has to be persistent, right? So with Kubernetes, what happens? This is what happens. This image is from the Microsoft website under the AKS or Kubernetes docs. All I did to this image was I highlighted the red bold rectangles there. It's so funny, I get confused with my shapes. My son is 6 and 5, and he keeps singing about shapes, and it just throws me off. So if I call it a circle, don't blame me. So if you look on the left-hand side, you see the cluster master, right? Think of that as, again, this is the master node, right? Now, you see on the right-hand side, you see the node. Inside the node, there's a pod, right? And then you see the persistent volume claim, right? And then underneath both of them, there's a persistent volume. And underneath that, you see two different storage types, right? You have the premium storage, managed disks, and then Azure files, right? So what this pretty much is saying is that Kubernetes works, and the way that you can actually use storage to not die when the server goes on or the node or pod goes down is to have persistent volumes, right? So if I create a Kubernetes cluster on my laptop, it'll use a local storage. So whatever I do to it, and I shut the cluster off and reboot the cluster, it'll wipe everything out again, right? It's like a temporary storage, right? A persistent volume is offered to the Kubernetes cluster from all vendors, right? So Microsoft has AKS, they offer the persistent volume to the Kubernetes cluster, right? As a persistent volume. And that goes to the cluster master, says, okay, I see you got, let's say 5 gigs, 100 gigs of storage here as a persistent volume, got it, thanks, right? And now the node that has a persistent volume claim, that acts as like a ticket. And he goes to the master, he says, hey, I need 5 gigs or 10 gigs or whatever I need, right? And then the cluster master says, okay, let me, oh, yep, I got the persistent volume, I got 100 gigs, here's 10. And that cycle just keeps going, right? So if the pod does not have a persistent volume claim, then you cannot get your data. So everything is, it's kind of, I kind of like to say that Kubernetes doesn't really, like, don't think of Kubernetes having storage, but it manages storage, right? As a manager, right? So pretty much what I said in verbiage form, right? So you can look over it later if you download the slide. Persistent volumes and then persistent volume claims. Now, in terms of security and getting into the cluster, right? BDC has 5 endpoints, 5 ways to get into the cluster, okay? Starting from the left, you want to get into the controller, you use AZ data, which is a command line interface. You download it, you install it. Actually, by the way, I have a YouTube page. I've uploaded a couple videos just on BDC. You can see the link on my site, but it's how to create a base machine and all this type of stuff. And I go over all of these in depth more. So if you have any questions, watch those videos. It'll make a lot more sense. And feel free to reach out to me again if you have questions. Moving over, gateway, NOx, management proxy. These use Again, you can connect to it via Azure Data Studio, and they have endpoints. So you have IPs with links. So when you deploy a big data cluster, it spits out a whole bunch of links with different URLs that you can click to, and one will be, your HDFS Spark, one will be this and that, and you bookmark these, and you can actually go and look at logs and dashboards and stuff like that. Moving over, the orange is, again, what us SQL Server individuals, we're used to using SSMS, Azure Data Studio, ODBC connections. Anybody coming to you, developers, I need to connect to the SQL Server or whatever, you give them that endpoint, right, which is an IP and a port. And again, for your app proxy, you can also get into there. But these are the only ways that you can actually log in to a BDC. No other ways other than these 5 endpoints right here. So this, your 5 points of entry, verbiage, you're going to read that later, pretty much what I just said. Features, let's start with data virtualization, okay? This feature right here, and I can't stress this enough for everybody listening here, this feature right here, data virtualization, is the reason why I got out, quote unquote, out of bed and dived into big data clusters, because I wanted to make sure something was very unique that big data clusters could offer, right, that no other service does. And this is concept of data virtualization, where you can actually query, right, other data sources. You can really start to minimize your use of SSIS, if not actually remove it completely, depending on what you use it for, and just use these data hubs, right? These data marts, this virtual layer of data that you go and query and bring into your big data cluster and store it, right? This right here is the biggest thing, and obviously this uses Polybase technology, right? This data virtualization, pretty much Polybase. So you will probably see some sessions and talks that are, data virtualization and Polybase. That's because it uses Polybase technology to do the data virtualization. But within the context of big data cluster, it even makes it just more, I guess, unique, right, and attractive, right? Somebody who's looking to dive into something cutting edge. Data lake, again, we have all different sources coming in, right? Unstructured, structured, Hadoop, right? Everything is coming in and being stored, right? So we have all these streams, right, from the different data sources coming into your big lake, right? Your data lake, and that's your storage pool, right? Data mart, again, like we mentioned, you ingest them, and now you have these different silos, right? And I, the more I talk about this, it's just still kind of, I guess, I get excited about this, is that it's all under the context of a big data cluster. So if you're a DBA and you're like, oh, I'm not going to do big data, you don't really, I mean, eventually I would love to get you down that path, and I'm going down that path, right? Because the environment, the world is changing, right? Everybody has big data, they don't know what to do with it, right? So we need to be that new type of DBA, right? The new data professional that can set it up, that can hook it up, right? And I want to tell you a quick story. I know I'm running short on time, but my neighbor is a data scientist for a pharmaceutical company, right? And I told him about big data clusters. He said, the funny thing is, the biggest piece is you guys. And I said, what do you mean by that? He said, for y'all to come in and actually set up my environment, right? That's where the big info, like deploying it, configuring, setting it up, troubleshooting, that's where it is. That's where a big chunk of it is. And then you just give the reins to the data scientist, hey, log in here, do your work, right? But to get that set up, that's where the big money is. So let's talk about licensing. We're talking about all the different instances running in nodes and this and that. How much does it cost, right? Now, licensing is, if you're familiar with it, it's probably the most confusing thing ever, right? SQL Server licensing or any, licensing issue. But I try to make it as simple as possible. Let's start off. The master instance must have core licenses, right? So if you have a 4-core machine on your master instance, right, that one instance that is the master that we all log into must run on core licenses, right? 2-core pack, those are the prices, must have software assurance or subscription. Now, the software assurance benefit, right? What is the benefit of software assurance? Provides customers with a limited big data node core entitlement for SQL Server 2019 big data clusters. What do they call it? BDN cores. What's that? That is a cost of $400 a year, and that's for a 2-pack, right? So what does all that mean, right? Because again, nothing more confusing than licensing, and 2 different companies never have the same licensing agreements and stuff like that. So this is just information. If it doesn't pertain to you, worry not. But let's start with enterprise. Let's say you're running SQL Server Enterprise, right? A BDC on SQL Server Enterprise licensing. Having software assurance gives you, or you're entitled to 8 times as many big data node core licenses as the number of licenses on the master instance. So if you're looking at the top, you see the SQL Server master instance has 4 cores, right? And so that's a master instance. Every other node on the bottom is a node for the storage pool, compute pool, data pool, any other node, right? And those are, let's say, 4 apiece, right? So you have 4 up top in the master instance. Since you have enterprise and software assurance, you're entitled to 8 times that number. So 8 times 4 is 32, right? So you get 32 cores you can use any which way you want, right? You just have to purchase 4 cores right there on the left-hand side, right? Oh, I'm sorry, the 4 on the left is what you have in the master. You get 32 in addition. You just need to purchase 16 subscriptions, right? At the 400 per 2, right? Again, confusing, I know. I even tripped up myself in the beginning, but review this information. If you want to show it to someone else, at least it'll give you a better idea, right? Talking points. Now, standard licensing. Maybe you're like, you know what? I don't have enterprise. I have standard edition of SQL Server. You can still run a big data cluster, but this time you only get 1 time. You don't get 8 times. You get 1. So you have you have a 4-core node, right? So you just get 1 times 4, right? So now you got 4 on your standard. You get 4 additional, right? And then you have to pay 44 for your subscription. Now, if you're running Azure, you're running on Azure. They make it very simple with this thing they call license mobility, right? Which whatever you got on enterprise or standard, you just move it on to Azure. Done. Very simple, right? So let's see. Like I mentioned, the learning curve for this is steep. Because if you're like me and you've just been on Windows, you've been using SQL Server on Windows, obviously, right? What else are you been using it on? And you're running SSMS, a lot of GUI interface and stuff like that. It's gonna be a little bit of a climb, right? To say the least, to get used to Linux and containers and Kubernetes and what is this and what is that. So I will leave you today with a learning path, okay? And this is what I used, right? That hopefully if you use, it can be of some benefit. Again, I don't want to leave today and you all just go and forget about it. I really believe this is the next thing of SQL Server, right? This is it. This whole adoption and symbiotic relationship, right, with Kubernetes and containers. And my call to action for you is, again, visit that page right there, mohammaddarab.com/BDC, right? Big data clusters, right? You'll see this session uploaded there. You'll see a list of all my videos and blog posts there that I post, and I keep that updated frequently. There's a newsletter in case if you're just kind of, again, lazy like me and you're like, you know what, I'll just sign up for a new newsletter. Whenever something comes out, I'll get it and then move on. I have that there as well. Learning path to BDC checklist. So these include, you can use the checklist any which way you want. Rip it up, take it out, whatever you want to do. Linux, containers, and Kubernetes. So like links that I use, books that I've read, some are free, some are like Pluralsight and things like that. It give you a start, right? To go and kind of dive in a little bit and start learning this, because I'm telling you, this is, and I've said this before in other sessions, I believe this is the future SQL Server in the sense that in a couple years from now, big data and SQL Server are going to be just like, I don't know, your left hand and right hand. It's going to be a part of the same thing, right? So I really, really suggest that you and advise that you all go ahead and look at that. I do really thank you all very much. Again, mohammaddarab.com. If you're on Twitter, reach out, connect. Let's connect at MWDarab. And if you care to leave some feedback for me specifically, or if you have any questions, just go and contact me there. And one thing I would like to say is, if you work for a company and you are, you want to have a one-on-one session with me and your team or your manager, your boss, anybody, a little bit more of a condensed version, more like a Q&A type of back and forth, reach out to me and I'll make that happen, put that on the schedule. So I hope everybody, it was beneficial, and that's pretty much my show.
Thank you, Mohammed. It was phenomenal today.
No problem, dude.
I'm not seeing any questions. Do you see anything, Kenny? I'm not seeing anything.
I hope people aren't sleeping, like.
Well, I hope not either. I wasn't. I thought it was great. Well, I want to thank everyone for coming today, and Mohammed for giving a great presentation. And I look forward to the next one with Tim. So once again, I hope you'll have a great holiday, and thanks again for coming. Bye.
Thank you, guys.